Okay, let's continue with our review to prepare for the quiz that we're having this week. So I'm gonna move on to number 6. Now take a look at number 6. On number 6, we have x to the 2/3 power to the 2nd power. So this is a review of the exponential rules that we learned about. And I noticed that I'm looking at a power to a power, that law. When we got one power raised to another power, the law states that you've got to multiply those powers. So this will become x to the 2/3 times 2. So I multiply 2/3 times 2. Now how do I multiply those fractional exponents? Well, let me make this whole number 2 look like a fraction. How do I do that? I put a 1 under, and then we multiply the numerators and multiply the denominators. So I'm gonna end up with the base x to the 2 times 2 is 4. 3 times 1 is 3, so x to the 4/3. You may be asked on the assessment to take the next step. And I say that because fractional exponents, what do I mean by a fractional exponent? An exponent that's a fraction can be rewritten using a radical. And if your answer choices give you those type solutions, then go ahead and rewrite this using a radical. Remember, that's your index, and the index is the denominator. And then the radicand is made up of your base x to your numerator as the power. So this is how we would rewrite it using a radical if we're asked to do so. And of course, we can't do any more with that problem. Remember, it says simplify. That means you keep going until you can't do any more. And in this case, we can't because we don't know the value of x. All right, let's look at number 7. Number 7, this is a problem that may take you back to Algebra 1, Unit 1, because we did simplify radicals in that unit. But that's been a couple of years ago. So let's look at how we're gonna work this problem. Now what I wanna do is, the easiest way to explain it is to break it apart. Notice this says the cube root of 343, x to the 12, y to the 6. And what I wanna do is, I want to go ahead and break it into the cube root of just the numeric radicand times the cube root of the x term times the cube root of the y term, just so we can clearly see what we're doing here. Now, cube root means that there's some number times itself again that will give us 343. And there happens to be a number that gives us that, and it's 7. So the cube root of 343 is 7. Check it. 7 times 7 times 7 is 343. All right. Now, so I've got that part done. Now, how do I get the cube root of x to the 12th power? Well, remember when we learned about our exponential rules, just like we went from x to the 4/3 can be written as this radical with the index having the denominator and the numerator being underneath with the radicand. But I can reverse this. I can actually write this that way. And what I mean by that is, just like x came from my base here, I can put x back in my base. Just like the numerator was 4, here the numerator is 12. The index became our denominator, so this index becomes our denominator. But look, 12 divided by 3 is 4. So that becomes x to the 4th. Okay, so all I did was reverse this rule that says I can take a fractional exponent and write it as a radical. I'm gonna do the same with this one. So how would this look? Well, y is my base, and it's gonna be to the 6 over 3 power. And what is 6 over 3? 2. So my final answer is gonna be 7, x to the 4th, y to the 2nd. So this is the cube root of this expression. Here's your answer. All right. And then number 8. This one is just directly like this problem. So the only thing we can do is rewrite it with a radical. And that's what we're gonna do. So in this case, remember, here's your radical sign. That's your index. That's where your denominator goes. And your base becomes your radicand. Numerator becomes your exponent. And that's all we can do with that problem because I don't know the value of x, and neither do you. So we're done. Okay? Now, let's come over to 9, 10, and 11. So here we're starting with our operations on complex numbers. Notice we're gonna add them. These are all complex numbers. How do I know? I see my real part, I see my imaginary part. Same here. So that's sort of a dead giveaway as to the fact that these are complex numbers. And recall, in order to add complex numbers, you add the real parts together, you add the imaginary parts together. So in other words, you're combining like terms. So I'm gonna rewrite them and show you that I'm gonna put my real parts together. So I'm gonna put my 5 plus negative 13 here. 5 plus negative 13, so the real plus the real, plus I'm gonna do the imaginary plus the imaginary. And how does that look? Negative 2i. Be careful, don't forget your negatives. It's easy to do, very common mistake. Plus negative 8i. I'm gonna put that in parentheses so you can see that I clearly put my negative 2i, my negative 8i, and then I'm adding them together. So let's get these results. 5 plus a negative 13. Remember your rules for adding and subtracting integers? So I know my answer is gonna be negative because I've got more negative than positive. So this will become a negative 8 plus, now I need to do this part, the imaginary part. So a negative 2 plus a negative 8, so I've got some negatives and more negatives. That gives me a total of negative 10i. And so that I don't have a plus and a minus sitting side by side confusing me, I'm gonna go ahead and just write this as negative 8 minus 10i. Because a positive times a negative becomes a negative. So my final answer will look like this. All right, number 10, same thing. We're adding complex numbers, so you combine the like terms. You put the real parts together, you add the imaginary parts together. So let's do it. So here I've got 7 plus 4. Okay, nice and neat. Plus negative 3i plus 10i. And notice the 10 didn't have a negative on it, so I didn't put one there. So what do I get? 7 plus 4 is 11, plus, let's do the imaginary part. Negative 3i plus 10i is 7i. And there's my final answer. All right, number 11, same thing. With this one, see if you can actually do this one with me, or help me out with that. So I'm gonna add my real parts together. I'm gonna add my imaginary parts together. And I like to rewrite mine. Negative 12, so this real plus this real. There's my setup for the real part. And we're gonna add the imaginary parts. This imaginary part, 48i, plus this one. And notice this is positive. I don't have to put plus a negative 21i, just put 21i. So our final answer here is gonna be negative 12 plus 15, well that's 3. 48i plus 21i, that's gonna be plus 69i. And there's my final answer. Now what I want you to be careful and wary of is that, notice I've got these i's. This doesn't become I squared. It only becomes I squared if you're multiplying them. If you're adding them, it's just the imaginary number I. So there's the answer for number 6 through 11. And then we're gonna look at subtracting, multiplying, and dividing on the next part.